Hello there, this is Dr. Seville, and we're going to do some more 3-point mapping. But this time we're going to do it on the virtual fly lab. And I know you guys are just loving the idea of doing another virtual fly lab, and so that's what we're going to do. The first thing in virtual fly lab is going to be to turn off all the annoying noises. So we'll do a little maintenance here. The screen directions go back to the activity, and we're going to see if we can do a 3-point cross. So we have to make a fly heterozygous for 3 genes, and eventually we're going to have to make that fly the female. And there's different ways we can do it, but the easiest way to do it is to take the female, and let's see, I want to do brown. Alright, one more time. Wild type female. Male, body color black. Eye color brown. Eye shape, wing size, wing shape, I think. Dumpy. Alright, so we're going to put those guys in there. Check out. Really do want to check out. I'm going to unpack my flies. I'm going to mate them. Then I'm going to sort my flies. They're all wild type. And they're all heterozygous for 3 genes. Crossing over only occurs in female, so we have to use a female that's heterozygous for those things. And we're going to use that in new mating. We're going to zoom out. We're going to return to the lab. And we're going to grab do a back cross to our males that we used. Oh, we just add right to the jar. That's good. Put them in there. Take them out. Sort the flies. Holy crap. Look at all those things. So we're going to analyze that data. We're going to return to the lab, and we are going to oops, I actually wanted to go to the computer and analyze results. There are no results. Return to menu. Return to the lab. Where's that? Ordered fly. So that's mate cross to female to wild type. We want to send that data to the computer. Yes. Now we can analyze the results, so we can ignore the sex. 1, 2, 3, 4, 5, 6, 7, 8. So those are 8 different categories, and as you can see, it looks like a 3-point cross. So these first 2 are going to be our parentals. These are going to be single crossovers. These are going to be single crossovers, and then these will be double crossovers. We know that they're double crossovers because they're the least. But there's actually quite a few double crossovers. So this is 4.8%, 4%, so that's a decent number of crossovers. So that what that tells you, that these genes are going to be pretty far apart. But it looks like perfect 3-point cross data, so you've just generated a problem that you can do on your own. All right? So I'm not going to do this problem. I've done tons of 3-point crosses, but you would go in here, you would say these are the parentals, these are the double crossovers. I can tell by looking at this that which one had to switch sides. Well, it looks like black jumped over to the other side because we got black by itself here, then we got brown and dumpy by themselves. So that tells me black's in the middle, and then you draw out your chromosomes, etc. All right? So that's how you set up a 3-point cross on VFL. Now, but I want to do one more thing. So I keep talking about how genes are, how there's no crossing over in males. And so then that gives you different kinds of results. So let's do the same cross. We will go to the computer, order some flies, get a wild type female, use a black-bodied male with brown eyes and dumpy wings, Add him to the cart. Check out. Yep. Toss him in there. Made them. Wait 2 weeks. Sort them. Now, last time we grabbed recombinants. But now I want to demonstrate what happens when you use a male and there is no recombination. So I have to zoom out, return to the lab, go in here, and we're going to we got a wild-type male that's heterozygous, but we don't have a wild-type female. I mean, a mutant female. Forgot to buy that. Let's see if we can go buy it. So we want a female that is black, brown, dumpy. Alright, so let us buy it. Awesome. So now we take that female. Oh man. It's not letting me do it. God, this thing gets on my nerves. Alright, so I can't use that female. Oh wait, something happened. It looks like I might have got lucky and randomly clicked on this enough because we've got the female was brown, dumpy, black. The male was heterozygous for all 3 genes. Sort the flies. Ah, yes. Look what we got. Send the data to the computer. Yes. Analyze results. Ignore sex. These aren't sex-linked genes. Okay, look at that. So what did we do? We took a triply heterozygous male and made it to a triply homozygous female. And all we got were brown, dumpy, black, and wild type. What are those? Those are the parentals. So the original parentals that we used in the original cross to generate this were black, dumpy, brown, dumpy, black, and wild type. And so we got no recombination between those things. So all we get are parentals. Alright, so that's what's going to happen. So let's do one more. Let's see. I'm going to do a couple more. So we will order some flies. I'm going to order, well, we'll try this one. We're going to try brown eyes, and we're going to try dumpy wings. I want to do it in a female first. So I want her to be, I want the female to be wild type. I want the male to be, I'll show you why in a minute. Check out, mate these together. Sort flies, they're all wild type. So now we're going to take a female. So this is just a mapping cross, and we're just a 2-point map. And so we're taking our females that are wild type, so they're heterozygous for the 2 genes that we're using. And then we're going to go back to the males that are brown and dumpy. So you guys have all done this a million times. Let those guys mate. Sort them out. Send the data to the computer. Yes. Analyze results. Ignore sex. So this is I thought these were a little bit farther apart, but what you can actually see is that these guys are super far apart. These are the parentals because they're the most. These are the recombinants because they're less. We're just doing a 2-point cross now between brown and dumpy. And what we end up with is about 40%. Now, this is nice that it gives you these percentages, and so that's about 40%. So that's super far apart. You should get tons and tons of crossing over between there. If they're a little bit farther apart, these recombinants would start to get so big that they would be so similar to the parents that they would look like they were unlinked. All right, so now let's do this the other way around. I want my female to be mutant. So she's got to be brown and dumpy. Add her to the cart. The male can be wild type. Add him to the cart. The reason I want to do that is because in the next cross, I want to cross back to this female who's homozygous recessive for both genes. So check out, yes, really, unpack, mate, check them out, sort them, wild type. Now I want to use a male in this cross. Using new mating, okay, zoom out, return to lab, go back to my incubator, and I want my females to be the testers, homozygous recessive. Add those, put them in the incubator. All right, I'm going to get these out. Before I sort them, you should know, so what did we do? We took our males, our heterozygous for brown and dumpy. Brown and dumpy are super far apart. When we did a female that was heterozygous for brown and dumpy, we got 40% recombination. All right, what do we get here? That'll happen. So our females, so that's our cross. Maybe I forgot to send it to the computer. All right, ignore sex. What did we get? Well, our original cross was a brown-eyed dumpy female to a wild-type male. We took the heterozygous males from that cross, back-crossed them to the brown dumpy females. So we're trying to look for recombination in the male. If we did it in the female, we would get 40% recombinance. If we used a male, we get 0 recombinance. And we get all parentals. Why is that? Because there's no crossing over in males. Okay, one more. I love doing my virtual fly lab. All right, one more. Let's take a couple things. Let's take, what do we got here now? We'll take ebony instead of black. We will take, and we'll make a female with ebony instead of black, and we'll do dumpy. They're all on different chromosomes. Sable's on the X, black's on the second, ebony's on the third. I just happen to know that. And then we'll do wing size, wing shape, dumpy. It's our female, and a wild type male. Check out, yes, mate them, sort them, and we got all wild type because they're heterozygous, and we want to use a male in this case. Now we could use a female, but the first one we're going to do is a male. Using new mating, okay, zoom out, return to lab. I used a wild type male in here, right? A wild type male. So I need my female to be dumpy and ebony. So now we're doing dumpy and ebony. I need my dumpy and ebony female. Put her in there. Mate them. Take them out. Sort them. Send the data to the computer. Yes. Look at the data of the computer. Ignore the sex. What happened now? We took dumpy and ebony, made males heterozygous. Last time we made males heterozygous for black and dumpy, we got all parentals because there was no crossing over. Now we're getting recombinants. We started with our parentals are dumpy and ebony and wild type. We know that because that's how we set up the cross. Our recombinants are dumpy and ebony. Now you might say, wait a minute, you told me if the ones that were the highest are going to be the parentals. Well, that's only true if the genes are linked. So the question is, are these significantly different? You know, the numbers came out a little bit odd. I would expect them to be a little bit closer, so let's see. These are a little low. So what we can do is we can do a chi-square analysis because this is showing a 1 to 1 to 1 to 1 ratio. So we took a male that was heterozygous for dumpy and ebony. We mated it to a dumpy ebony homozygous female. If these genes were linked, we would get no recombinants because there's no crossing over. But we are getting recombinants. But there's no crossing over. So those recombinants didn't come from crossing over. So where'd they come from? Independent assortment. Because dumpy and ebony aren't on the same chromosome. So that's my hypothesis. My hypothesis is that this is independent assortment. Test it. Level of significance is 0.16. So we accept that hypothesis, or we do not reject it. It's a little bit kind of low, on the low side, but it's still way above 0.05. So we accept that. All right, so it's independent assortment because these are in different chromosomes. So that means if we do the cross the other way, using a heterozygous female cross to a tester male, then we should see the same thing because we're going to have independent assortment. And crossing over has nothing to do with it if the genes are unlinked. And so we can use this cross, we can use even genes that are super far apart, and we can test out whether they're linked or not by using a male which suppresses crossing over, and then if they're linked, we get all parentals. If they're unlinked, they look unlinked. All right, so I'm going to make you suffer through one more. Do the same cross, but this time we're going to make our male mutant for ebony, and we're going to have to go back and let's see if we can get away with it. So we'll make them ebony and dumpy, female wild type. I think I'm going to have too many flies. Check out. Made them. Made those guys. So now I want to use a female because I want to show you. So we last time we used a male and we crossed it back to the female. Now we're going to take a female, which is a legitimate mapping cross. Use her in a new mating. What I mean by legitimate is that if we were trying to map the genes, we would get crossing over. And see if I can find a nice dumpy ebony male to hook her up with. See if I can get that guy. There we go. Single fly in search of dumpy ebony male. And the new mating. Sort the flies. Send the data to the computer. Check them out. Ignore the sex. And there you go. Very similar. This time we started out with, so our dumpy ebony are parentals, our wild type are parentals, ebony is a recombinant, dumpy is a recombinant. Is this a 1 to 1 to 1 ratio? 1 to 1 to 1 to 1? By golly, yes it is. Lo behold, it is a 1 to 1 to 1 ratio. Why? Dumpy and ebony are unlinked. So if you use a wild type female or a wild type male that's heterozygous for those two genes and you do a test cross, you get the same thing. Okay, so that's really, really, really the end.